Okay, we're going to work on lesson 2.3 and 2.4, much of which is review from Algebra 1. The idea of slope, we should remember about slope from back in the day. Biggest thing is given 2 points in order to find the slope. It's going to be y2 minus y1 over x2 minus x1. Remember, slope is the change in y over the change in x. That's why we subtract the y's here, subtract the x's there. Vertical change over horizontal change, also known as rise over run. Variable m is what's used, and we'll see that in y equals mx plus b coming up shortly. Remember, you have to rise before you run. Finding the slope given two ordered pairs. Identify your x's and y's. y2 minus y1 over x2 minus x1. Make sure you're consistent with the way that you're subtracting, otherwise things will go awry. Now I did these points first as x1, y1, but you also could have done it as 2 minus 4 over 3 minus negative 6. You get negative 2 over 9. Both of these are equal to negative 2/9, and that's your slope. We always leave our slope as a fraction. Next one, we've got m is equal to negative 4 over 1 minus 1 over negative 3 minus 5. Negative 5 over negative 8, the slope is 5/8. Finding the slope on a graph, very easy. Find 2 points. Find any 2 points that it goes through. I see a point right here. I see a point right here. We're looking at rise over run. Up is positive, down is negative, left is negative, right is positive. Up 1, right 1, 2, 3. Rise over run, up 1, right 3. Slope is 1/3. If I had gone the other way, down and left, I get down 1, left 3, and I get positive 1/3. Piece of cake when you find it going through the origin. Pick the origin, pick another one here, down 2, right 1, down 2, right 1, negative 2. Remember that you can look at the graph and you can say this is going up from left to right, has to be positive. It's going down from left to right, has to be negative. Finding the slope from a table, you have to watch out if they're not counting regularly. So this is the y, so I'm looking for the change in y's, plus 3, plus 3, plus 3. Change in x, change in x, minus 1, minus 1, minus 1. Slope, change in y over change in x, 3 over negative 1 or negative 3. The slope of this one is negative 3. Down here, change in y, plus 1, plus 1, plus 1. Change in x, plus 2, plus 2, plus 2. Consistent change means linear. Change in y over change in x, 1 over 2. Slope is 1/2. So you can do it on a graph, you can do it on a table, you can do it with points. For all of these things, you are focusing on this right here. Remember, the triangle is the delta symbol for change in. Change in. Graph, rise over run. Table, change in y, change in x. Points, y2 minus y1 over x2 minus x1. Now we've got to work backwards on this guy. They give you the slope is 1 equals y2 minus y1 over x2 minus x1. I have 1 equals r minus 6 over 3. Solve for r times 3 times 3. 3 equals r minus 6 plus 6 plus 6. R is 9er. Check your work, plug it back up in here. 9 minus 6, 5 minus 2. And we're good. Same idea here. Negative 2 equals y2 minus y1 over x2 minus x1. You could multiply both sides by 4 minus r if you wanted to get that out of there, or you could cross multiply. Cross multiply. So I'm going to have negative 2 over 1 equals 4 over 4 minus r. 4 equals negative 2 times 4 minus r. Solve for r. 4 equals negative 8 plus 2r. 2r is 12. R is 6. 6. Check your work. 6. 1 minus negative 3 over 4 minus 6 is 4 over negative 2 is negative 2, and we win. Winning. R is 6. Good times. Good times. Vertical and horizontal lines. Got a little bit more going on here. First one. If you just are a good little soldier and you're going to do m equals r2 minus y2 minus y1 over x2 minus x1. Oh no, we get 4 over 0, which is undefined. Plot those points. 3, 2. And 3, 6. Holy cow, it's a vertical line. Excuse me. Vertical lines have no slope. No slope. Rise over run. We rise 4, we run 0. You are not allowed to divide by 0. Vertical lines have no slope. The slope is undefined. Horizontal lines, on the other hand, y2 minus y1 over x2 minus x1. 0 over 6 is 0. Plot the points. Negative 2, 5. 4, 5. It's a horizontal line. Horizontal lines have slope of 0. 0 rise, run of 6. Horizontal lines have a slope of 0. Good stuff here. Great material. Love it. Loving it. Loving it. Oh, there's a funny joke. I thought we discussed that you have to stick to slopes that pass the vertical line test. 2.4, next lesson. So the 2.3 is all about slope. Slope is something that you have seen in the past. That's why we buzzed through it pretty quick. Now we're going to do slope-intercept form. Why do they call it slope-intercept form? Because m is the slope and b is the y-intercept. And that's going to be where it crosses the x-axis. So we have a slope and we have an intercept. Y equals mx plus b is the most common equation that you have used throughout your algebraic years. Write the equation in slope-intercept form without a table. Oh no, not that. Anything but that. I have a y-intercept. This is the y-axis. This is the x-axis. The y-intercept is 1. B is 1. Find another point. I got one right there. Rise over run. Up 1, right 1, 2, 3. M equals rise over run. We know it's going up from left to right. It should be positive. Y equals 1/3 x plus 1. We have a slope. We have an intercept. We have an equation. It's wonderful. Next one, again, I got a slope of 1. Coincidence? Yes. B equals 1. I have a point there. I've got a point, I think it's all the way up there, actually. Up 1, 2, 3, 4, 5. Left 1, 2, 3. So my slope Up is positive, left is negative. It's negative 5/3. Y equals negative 5/3 x plus 1. We should check another one. 1, 2, 3, 4, 5. 1, 2, 3. Hey, winner, winner, winner. We're good. Y equals negative 5/3 x plus 1. Next one, you use this less in Algebra 1. We start using it more in Algebra 2, and it really picks up steam in pre-calc. Point-slope form. So slope-intercept form had a slope and an intercept. So point-slope form has a point and a slope. So our slope, again, is m, is the slope. And then we have another point xy. So it's given this other point xy. This is a point that the line passes through. Any point on the line. Please note the minus signs are part of the formula. Hey, wait, where else do we see y is being subtracted and x is being subtracted? M equals y2 minus y1 over x2 minus x1. What happens if I multiply both sides by this thing? Look what I get. M times x2 minus x1 equals y2 minus y1. Oh my gosh. The point-slope form is just the slope equation rewritten. Y minus a y coordinate equals m times x minus x coordinate. Who would have thunk it? Wow, that's great stuff. Whoa, whoa, whoa. I think I passed up my stuff here. Okay, write and graph in point-slope form. It's as easy as pi x1 y1 m. Y minus y1 equals m times x minus x1. There should be a minus in front of this. Y minus y1. There we go. So really it'll be y plus 2 equals 1/4 times x minus 3. The beauty of this, if we wanted to distribute the 1/4 and subtract the 2, boom, we're in point-slope form. I can graph this by going onto the graph. I'm going 1, 2, 3, 1, 2. Now apply the slope of 1/4. Up 1, right 4. And I could also go down 1, left 4. And then I have my line. Isn't that wonderful? Isn't that fun? Next one. I can do y minus y1 equals m times x minus negative 2. Are you okay with me just going plus 2 right away? Don't tell anybody. Negative 2, positive 1, apply the slope. Down 6. Right 1. Up 6. Left 1. Look at that. Isn't that wonderful? Isn't she lovely? There it is. Boom. Now, the nice thing about point-slope form, I was given a point and a slope, and I could shove it right into this equation, but we could also very easily distribute the 6. And then add the 1. And I get y equals negative 6x plus 13. Excuse me, minus 11. That should say minus 11. First mistake of the year. Negative 6x minus 11. If you look down here, minus 11 is going to be way down here. So actually just using the point and the slope, that's the way to go. That is the way to go. All right, graph and point slope. Please note how they want you to write it. The first thing we have to do is we have to calculate the slope. And I would do 3 minus negative 2 over 4 minus 9, which is 5 over negative 5, which is negative 1. So now I've got a slope of negative 1, negative 1. And I can use any point. I choose to use this point because there's no negatives in it. And I can do y minus 3 equals m times x minus 4. Distribute the negative 1. Y minus 3 equals negative x plus 4. Add 3. Y equals negative x plus 7. Look at how easy it is to get it into point-slope form. I have a slope, I have a y-intercept. Same thing down here. Y minus y1 over x minus x1. Negative 7 over negative 1, that's 7. Y minus y1 equals m times x minus x1. Now it wants it in point slope. Distribute the 7. Y minus 5 equals 7x minus 21. Y equals 7x minus 16. There we go. Slope 7, y-intercept of negative 16. Okay, how are we going to graph an equation in point slope form? All you have to do is graph the point. Please please remember the negatives. Please remember the negatives. So I've got a point at 4, negative 7. So you can just go to 4, negative 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And now apply the slope of 2. Look at that. There's a 2. Up 2, right 1. Boom, you got a line. Isn't that great? Next one, you can go to the point of 1, 3. x1, y1, slope is 4. 1, 3, slope is 4. 4. It'll be a steep one. There you go. Okay, standard form, ax plus by equals c. It is very important that you understand a couple of rules. A, b, and c are all integers, and a is positive. So this one right here means a's got to be positive. A's got to be positive. Also, they're all integers. Also, they need to be reduced. There's a greatest common factor of 1. So if it's 2x plus 4y equals 6, you can divide everything by 2, right? It turns into x plus 2y equals 3. X plus 2y. There's a plus there, obviously. So this is standard form. It's very important that you do not have any fractions or decimals. That's what it means to be an integer. You can get the slope and the y-intercept directly from A, B, and C. You're going to want to write this down or have it handy, because if I had ax plus by equals c and I solved for y, I'd have by equals negative ax plus c, and then I'd divide by b, negative a over b, x plus c over b. That's where these two things come from. So you can graph the following equation. You can find the slope. The slope will be negative a over b, or 3 over 2. The y-intercept will be c over b, or negative 6. Graph the line, down 6. Apply the slope, up 3, right 2, up 3, right 2, and 2, and graph it. But it's all about using these formulas. Pick them apart. Right here, read the graph. Read and graph. A, B is negative 1, C is 6. So we have the slope, negative A over B. That's negative 3 over negative 1, which is positive 3. Slope of 3, y-intercept of c over b, or negative 6. Graph y equals 3x minus 6. There you go. Next one. Slope negative a over b positive 1/5. Y-intercept c over b is -2. Plot the point, -2, apply the slope, up 1, right 5, connect the dots, and we're rolling. Last thing, parallel and perpendicular. Parallel and perpendicular. Parallel and perpendicular. Parallel lines. We know parallel lines never intersect. Parallel lines never intersect and have the same slope. Perpendicular lines. Slopes are opposite reciprocals. Reciprocals mean they would multiply together to get 1. Opposite means their signs are different. Their product is -1. So if you're not sure, multiply the slopes together. If you get -1, you have perpendicular lines. So we need to identify the slopes of these things. The slope of this guy right here. Whoa, that slope is 3. This slope is -a over b, positive 1/3. They're reciprocals, but are they opposite reciprocals? Nope. The answer is neither for the first one. Up here, slope is -2. And then down here, -a over b is -2. Oh, if they're both -2. Oh, wait. First mistake of the year. Look at, it's not written in standard form. Oh my gosh. X plus 2y equals 5. Now do it. -a over b. That's -1/2. Again, they're reciprocals, but they're not opposite reciprocals. That's neither. Last one. Multiply the two slopes together. Because I can't do a reciprocal of a decimal. That's terrible. I get -1, which means these are perpendicular. Perpendicular. That means they're going to form a 90-degree angle when they intersect. Good stuff. Good stuff. Good stuff. Write the equation in slope-intercept form for the line that passes through the given point and is parallel to the graph. Parallel lines. Let's do the top one. Parallel lines. I know I'm going to have a slope of -4, and then I'm going to have this point. So I'm going to do y minus y1 equals m times x minus x1. And then we have that point's in, now we want to simplify it. Y minus 5 equals -4x minus 8y equals -4x minus 3. And you can graph. -3, down 4, right 1, up 4, left 1, and boom. Parallel lines, same slope, very important. Perpendicular lines, slopes are opposite reciprocals. So first find the slope. M, no, not yet. M equals -a over b, which is 1/6. The slope of my new line needs to be the opposite reciprocal, -6. Y minus y1 equals m times x minus x1. Y minus 4 equals -6x plus 12. Y equals -6x plus 16. There's my perpendicular, opposite reciprocals. We're harvesting the slope in order to use for later. And that's it. It's a big lesson. You got lots to work on. Enjoy.